Hello, everybody, and welcome to Circuit Lab and Machines live Q&A. Today, I'll be covering specifically how to make a potato battery. I will also be covering um, how to make measurements for a Class 1 lever and giving some tips. But I see we've already got some people who've logged on. If you've got any questions, feel free to put them in the chat box. Um, Please do not put any personally identifiable information on here. And also, as always, make sure that you are you are doing that, excuse me, that what I say is just provided to augment what your coach is already telling you. If if in any way, shape, or form I contradict what a coach has told you, follow what the coach is telling you. Nothing I say on here is part of the rules for Science Olympiad. So anything I put on here is just my own opinion. And so it's just an effort to try to help you. See, we've already got a couple of folks in here. And so the question I have is, are there any questions? Okay. All right. So since there are no questions, what I'll start off with is let's talk about how to make a potato battery. Okay. This is a very common circuit lab hands-on activity. I went down, purchased two potatoes. They don't have to be pretty. And so I always try to grab potatoes that nobody else wants. And I think both of these potatoes together cost me 70 cents. Then you will also need a multimeter. This is a $7 or $8 multimeter from Harbor Freight, which will work just fine. The first thing I'll do is I'll turn the multimeter on and I will set it to DC voltage for 2000 millivolts. And so what you do is you switch this over to where it says DCV. Okay. The other thing is make sure that it's plugged in well here. Make sure that you are not using the amp hookup, which I would, if I wanted to, I would remove the red lead and put it there. And then one thing I do is I get alligator clips and I attach them to the end of my leads because it's just a lot easier to work with alligator clips. And so now, if I want to measure the voltage here between my two leads, and I hold my two leads together like this, you'll notice that the voltage is exactly zero. Okay, so question is, how do you create a battery using a potato? So batteries almost always have some way there's usually an acid bath or something that is free hydrogen and hydroxide ions. And so that's why in a car battery, you might have acid, or in like an alkaline battery, you've got some acid in it. Most vegetables and most fruits are very acidic. Okay. That's why they taste so good. And so this has acid in it. Now, what you also need is you need two dissimilar types of metals. So this is a steel wire and this is a copper wire. Okay. And then all you really have to do is stick the one metal in one part of the potato and one in the other part of the potato. Make sure they don't touch, okay, because you don't want to short out the circuit. But what's happening is that each one of these has different levels of activity on them. Okay. So in other words, there's a different voltage here than there is here. And that's what creates the battery. Okay. I then use my clip and I clip one lead to one side and the other lead to another side. And you will notice I now have 1 volt. It's 1.027 volts created by this battery. Okay. Now, That's interesting, but I've got another steel rod here, okay? What I'm going to do is I'm going to replace the copper with steel. So now it's the same on both sides. Now these should have about the same activity, and I will notice that now my voltage is virtually nothing, okay? It's 0.0057. So it's virtually nothing. So that's why you have to use different types of materials. And if you pick materials with different activities, what will end up happening is the wider the difference in activities, the more voltage you'll create. So we'll go back and we'll create it for real, and I'll put the copper back in, and then I'll take my second potato and I'll do the same thing to it as I did with my first potato. Okay, so now I have two potatoes. And what I'm going to do is I'm now going to connect the two potatoes. And here we go. I'll let you look at this. I will now connect the two potatoes to create a 2-cell battery. Okay. And so what this will do is that this allows me to get the voltage from this potato and the other potato and add them together. And now, when I hook them up, I get 2 volts, or actually 1.981 volts. So this is a 2-cell potato battery, okay, where each of the potatoes acts as an individual cell. We could create many of them. Now, if I put them in parallel, an odd thing will occur, okay? And if I put them in parallel, what ends up happening there is, and that would be where I would do something like this. I would attach this one to this one, and and this one to this one. And it violates one of our rules that we should never put batteries in parallel with each other. But you'll notice I now have 1 volt, which makes perfect sense because they're in parallel, so the voltage is forced to be the same. And actually what's happening is that whichever potato's got a slightly higher voltage is charging the other potato. Okay? Now, this configuration, the only reason you would do this is if you wanted to get exactly 1 volt, but you wanted more potential amperage. Because you got to remember, these potato batteries, they usually don't put out a lot of amperage. Now, are there any questions? Now, for the acidic solution, this would be considered a wet cell, these 2 potatoes, because as you can see, the acid is wet in them. Okay. The other thing that I would tell you is that as a general rule, we could replace it with like a can of Coke. So you'll see Coke cell batteries where you'll pour Coke in or any type of salt water or anything else that's acidic, and you can create batteries out of them as well. Again, using 2 dissimilar materials. The one thing I will tell you is that if you ever create one of these, or you create like a lemon battery or what have you, do not try to eat the potatoes. Like today, after we're done, I'm going to go put these out in the compost pile because we can no longer eat these potatoes. You can, however, just clean off the metal and reuse it. Do bigger potatoes give off more voltage? Usually no, because the voltage is actually determined, for the most part, by the amount of acidity, as well as the differing materials. So, like if I use like different types of materials, different types of wire, like let's say I used aluminum and copper instead, or I used lead and something instead, I would probably get a different voltage. You will find out that like potatoes and lemons and other materials each give off different types of materials. Why don't you want to eat the potatoes? Oh, the reason why you don't want to eat the potatoes is that little pieces of, or basically you're rubbing copper against it. Okay. And if it's reacted, it's just not a good idea. Same reason why I would not recommend licking copper wire or licking aluminum wire. Good questions. Very good questions. All right. Are there any other questions in Circuit Lab? Okay. We seem to have had more people join. For those of you just joining, we just went over how to make a potato battery, and we showed how to make a single cell potato battery, which is about 1 volt, and how to make, you would probably not die, but it's just not a good idea. For when we get to machines, how would you recommend that we attach the weights to our scale in competition? Very good question. All right. So if there are no other questions for Circuit Lab, I will now switch over to machines. So what you'll notice here is that I have a couple of, and these are the personal ones I've made up using Walmart grade zip top Ziplocs. So you'll see with a little eye hook and then a zip tie on top that I usually glue here so that it won't get any smaller. So you can screw it into the top and it really holds well. Amazingly enough, these extra small containers are able to hold enough steel BBs such that I can get up to the 800 grams even with these, and they're very small. But even these larger ones, you can use them as well. These are small size. These are extra small. Definitely don't use the bigger ones. Like here's a large one. I just use this to carry all my BBs. One of the first things that you always check if you're creating one of these is you want to make sure that a golf ball can fit through the loops on each of these. And I usually bring the golf ball with me to competition so I can show folks. So that's how you know how big these loops will be on top. You don't have to use zip ties. You can also use like fishing line or something else. Would the weights in competition look like these? No, they don't have to look like these at all. These are just the ones that I create. If you ever have a situation where I'm your event supervisor, yes, it will look like this. But what I'll probably do is I'll probably paint the inside so that you can't tell the difference in ratios. Like if you look at these two, you know that this one has more mass than this one. Okay? You don't want to give that away. Okay? Now, so here is my old teens lever. It's a class 1 lever. Okay. And what you'll see here is that it's made fairly simple. Okay. This is an aluminum U-bar construction. So it's very light, but it's very strong, won't bend. And then for my fulcrum point right here, this is just a brass rod. And so you took some 2x2s and we cut out about a foot long piece here, about a foot long here, and about a foot long here. So all 3 of these pieces are the same. And then just something small in here to hold them up. And then you're just using deck screws on the side here. We screwed in deck screws on the side to keep it from rotating. Okay. So this holds up really well. Actually, it held up so well that we were able to break it out of storage after 4 years, and it worked perfectly, breaking it out. Now, the weight of this part of the bar, back to the fulcrum, or the mass, is more than this for the same amount of aluminum. So you put on a counterweight, okay? So this is a fixed counterweight. You'll notice I put the counterweight on top such that it won't interfere with whatever I hang over here. You'll notice that I also made the counterweight such that it's about in the middle. So this counterweight weighs almost as much as this entire bar. Okay. But what it does is it allows me to hang a mass over here without having to get in the way. If you hang the counterweight on the farther end, you can get away with a lighter counterweight, but then a lot of times it'll get in the way of your mass. So what do we use for the counterweight? In this particular one, we just used a big old bolt and some big old washers and a big old nut. And then I can tighten it down by hand. And then when I get ready for competition, I want to make sure it's balanced. Because let's say in transit, okay, let's say it's out of balance like this. Well, that's no good. So what you do is that you then get in here and you can move it slightly forward or backwards until it's fully balanced with no weight on it. So you'll see that right here, it's pretty well balanced with no weight on it. Now, why put the fulcrum near the rear end instead of the middle? That's a great question. Because if you look in closer here, I have put in fixed ratios here. And this is where you're going to make all your measurements that's going to go in those chart scores. Okay. So what you do is that you put a weight, like this particular mass is 100 grams. Okay. Now you'll notice at the end here on the heavy end, if you will, I have a little notch right here. That notch means that I will always put the heavier mass in the same location. Always. Such that when me and my partner are doing this, you'll have one partner who's sort of in charge of making sure you got one partner who's in charge of the long side. This will be the lighter. You got one partner who's in charge of the shorter side. That's where you're going to have the heavier. What's going to end up happening is that when you start in competition and they say go, the first thing you're going to do, by the way, you can see why it's very important to have these things balanced. Hold on a second. Oops. Is that I'm going to take these two and I'm going to figure out which one's lighter and which one's heavier. This one's the heavier. And so I put it here. I put the loop here on the heavier side. And that's what one partner would do. The other partner will put it on this side and then move just the lighter side until it's balanced again. And that's about it. Now, since I've already made multiple measurements, I can look on here and see that I came out with 1.95 for my answer for this to that. Now, there's a couple things I may have done wrong here. I didn't have that one exactly on right, so I need to move this out a little bit. And so it's dead on accurate at 2.0. You'll be able to make those measurements after you've practiced a lot with your partner in under like 10 seconds, 20 seconds. One of you would then write it down, and then you grab the other mass. And the first thing you always ask yourself when you grab that other mass is which one's heavier. So the first one was 2-to-1. And then I got these two masses. This one's a lot heavier. So I know I'm going to put it over there. And you notice I'm sort of fumbling around. Hopefully, I've practiced a lot with my partner, and I won't be making as many fumbling mistakes. And so this one here, so remember, one person is making sure this one's exactly in the right location. The other partner is trying to see exactly what the ratio should be. And if I look here, the ratio is 4-to-1. 4-to-1. Okay. Here, let me back up so you can see what 4-to-1 looks like. So this, and if you look at it, the distance from here to here is 4 times the distance from there to there. It's very close to that. Now, this is just how I do it. Other people will actually make measurements and do calculations, but that slows you down a little bit, and you're also more likely to make calculator errors. The thing that's nice about this, as long as you can figure out which one's heavier, like if you hold these two and you go, yeah, this is the heavier one, this is the lighter one, it goes a lot faster. But when making these measurements, cannot emphasize this enough. You and your partner keep practicing. Who's got that better handwriting? That's who writes it down. Who can figure out which one's heavier or lighter? That's the one who hands it off. Who's better at one side? Who's better at balancing? You're going to find that you're each better at something. The other thing that I would recommend, okay, is do not time yourself or practice for time until December. Between now and December, you're just worrying about accuracy. You are charting the distances, putting it in your chart book, and then eventually, when you get those ratios down right, you put little marks on your lever, and then you can say, well, this is 2-to-1, this is 3-to-1, etc. Now you'll notice what this team did. They also put in the decimals. So like they don't just have 2-to-1 here, they got 2.1, 2.2, 2.3, etc. And then what they do is that if it's between 2.1 and 2.2, they put 2.15. Okay. I apologize that it was hard to see the marks because you will notice I'm not in my normal place. I don't have the same level of lighting. So I was visiting a friend of mine today, and so he graciously lit me his room, and so that's why I don't have as good a lighting. So how could you tell if it's perfectly even? Very good question. Guess what? What's the first mark I put in there? Is 1-to-1. So there you got 1-to-1. I also did 0.9 and 0.8, 0.7. Why? Because the absolute toughest one to do is if they're almost equal. So like if it's really, really light, okay, like this is 100 grams. This is 200 grams. Okay. 300 grams, 400 grams. So if I give you 1 and 400 grams, actually that's a lot easier and you'll get better results. I gave you 2 100-gram ones, that'd be a lot tougher. Okay. And it's okay if you haven't started your machine yet. My recommendation, study the material. Honestly, as I showed you, I've seen people who've built really good levers with wooden pieces here. Okay. I've seen some people who've used rulers. The only reason why my team went away from using rulers or yardsticks, okay, was one, they were going to put their own legend on anyway, and they didn't want to get confused. And the little notches in it would sometimes cut fishing line if you used fishing line instead of zip ties. The other reason that they didn't like it is that after a while, the fulcrum point here would get wobbly because the wood rubbing back and forth this way would start to open up that hole that the fulcrum sits in. Should the lever be as light as possible? Well, I'll tell you, here's the most important thing. One, make sure your lever is stable. Okay. It'll be put on a table. So make sure it doesn't wobble. Okay. This is actually about as skinny a lever as you can make that's still pretty stable. Okay. I've seen some people use a big piece of plywood on the bottom That usually provides a good base. The second thing is make sure it's high enough, okay, that if they give you a big thing like this, it doesn't touch the table. Now remember, the height of the weight of the mass can be 15 by 15 by 20 centimeters. So I like to give myself at least 30 centimeters, okay, which is about a foot, okay. Now, you do want the beam to be as strong and weigh as little as possible. Why do I want it to weigh as little as possible? Because that way I don't have to get a bigger counterweight. The lighter it is, the less of a counterweight that I need, and usually the less loss I will have. But the counterweight really sort of offsets some of the weight. That's why I was able to go with aluminum, and I didn't have to go with something super smaller. Okay. The other thing is that you want to make sure this fulcrum point right here has as little friction as possible. So my team, what they actually did before they went and made measurements, they put a little oil in there. Now, here's the one problem. If you're going to oil your fulcrum point during practice, that's what you had to do in competition. So the morning that they showed up in homeroom, they did the same oiling procedure. Okay. The other thing is make sure that you can make adjustments. So like make sure that it's less than 80 centimeters if you're in Division B, and make sure that each individual beam is less than 40 centimeters if you're in Division C. Will an inclined table be a challenge that we have to face? An inclined plane could be a question, and they could do it as a hands-on activity. However, I have hardly ever seen one actually used outside of classrooms, so I don't think you have to worry about that other than just being able to solve it on paper. Remember, for Division B, all inclined planes will have to be frictionless, whereas Division C can have friction on their inclined planes. Okay? The tables where you are doing your measurements are always going to be level, but guess what? Even if this table was like this, as long as the bar is level, I could actually do the same measurement just like this. See? So the table will be level, but even if it's not exactly level, if your lever is nice and balanced. The other thing I would recommend for that lever, get some sort of sturdy box to contain that entire lever to make sure that in transport it's not messed with. We actually went to one of those UPS packet stores, and they made a custom box and then gave us like those big bubble wraps. We could use that, and it kept the lever from moving too much. If the table's not perfectly horizontal, again, that won't impact you. Now, I did see something in competition that I thought was a really cool idea. There was another team. What they did was they put right here at their fulcrum point, they put a small little level with a bubble so that they could really balance it well. Now, the thing is, generally speaking, this thing's going to be so accurate, like you'll be able to tell like this is pretty balanced right here. So you don't necessarily need a level. And if you do have a level, the one problem you have to remind yourself of is don't spend so much time messing with little micrometers. If you already know it's 2.15, that's 3 significant digits to go. Okay. If you know that it's 2.15, knowing whether it's 2.15 or 2.147, that's not gonna make you any points. So what you do is you get very accurate, and I'd say get about 97 to 99% accurate, and then go make your other measurement. Any other questions? What can the ratios range between? Okay, well, if you go to the rules, you'll notice that there are different ratio ranges for different levels of competition. My personal recommendation, until you get ready for state, do not build a lever that's ready for state. Okay. you'll have to remember, you saw that one actually had some ratios that were greater than 4-to-1. But if you're going to an invitational or you're going to a regional, the maximum ratio that you'll need in Division B is 4-to-1. In Division C, you'll need 8-to-1. But what you can do there is that you can build a Class 1 lever that does 4-to-1 here, and then hook it into a Class 2 lever that's always at 2-to-1. And then that compound ratio in B and C, you'll get 2 times 4, and you'll get 8-to-1. Any tips on the written test? My recommendation is to study the written test a lot. Most of the questions that you'll run into are simple machines questions, even on the compound machines test. So my recommendation is you start learn the lever, learn all 3 classes of lever, learn conservation of energy, learn what mechanical advantage is. And then I actually put on the national website, soinc.org. You go there and you go to and you go to the machines event page. What you'll find is I made 7 classes that cover all the simple machines, including screws. So it covers levers, it covers pulleys, it covers wedges, it covers inclined planes, and so hopefully that would be useful. Now, the other thing is that I would also recommend you go to Scioly.org, and they have a host of old questions. Just remember, it wasn't named machines previously. It was named simple machines and compound machines. And you can go get old tests, and you can practice with a lot of those old tests. Make sure you build up your binder. And in fact, I even give some helpful hints on how to build a binder in those lessons that I put out there. I also put out there what I call a homework generator. It's an Excel spreadsheet. You can pull up that Excel spreadsheet, and it will be level 1 for levers, and it's real simple lever problems. And there'll be level 2 levers, and then which are more complex, and then it will be pulley problems, etc. And there's a random number generator such that it generates random questions, gives you the answers. If you can do those sheets, it gives you a chance to practice pulley problems, etc. Now, for your binders, I generally recommend about a 2-inch binder up to a 3-inch binder. Much bigger than that, they usually get a little tougher to get a hold of. The most important thing with a binder is make sure that it's usable for you, okay? The first thing I always tell my teams, put in the rules. If you got any FAQs and clarifications, you put them behind them. Then you're going to want to put in all the formulas that they're going to need, all the constants that they might need. And you go through and you continually keep adding things that you need. Like you'd have a whole section on levers and a whole section on pulleys, because you never know what they're going to ask you. They may ask you for a gun pulley or a block and tackle or a gin pulley or double block and tackle. And you have to figure out what those things are. And a lot of them, they may even give you things and say like a windlass, which is a sailing term. And so I would recommend that anytime that you're doing one of these tests and you have all the answers all written out, you put that in your binder. Make sure it's nice and tabbed. And the best thing I would say is at least once a week, do a binder check to see if you can find whatever you want. Like have your partner quiz you and see if you can find everything in under 10 seconds. Oh, the website is the soinc.org. It's the national website. If you go up to the main menu box in the upper left-hand corner, you click on it, and it comes down. You see Division B and Division C events. You go either one. You go to machines. There will be all 7 of those sets of slides I was talking about, plus another practice number 8, where I talk about how to build a lever in much more detail. And I even tell you like how much stuff costs at Lowe's. Okay. Because everything you saw there was just bought at Lowe's, except for the brass bar in the middle. Yeah, I got that at a hobby shop. Okay. And so those are all at soinc.org. I'm glad you know what a windlass is. Okay. Any limitation on the number of sheets in the binder? No. But I will tell you, the largest binder we've ever seen was 2 feet thick. It was a team, it was for It's About Time. I actually have a picture of that that I show in a lot of the coaching clinics I go to. The team did horrible because they couldn't find anything in there. So the most important thing is that anything you need to find, you can find in about 10 to 15 seconds. And so, like, I would just keep quizzing each other back and forth. Hey, can you find where a windlass is? Can you find a wheel and axle? The formula for a wheel and axle. Can you find how gears work? And I generally recommend that, you try to get as many pictures in there as possible. Because again, you're going to be trying to solve a problem and you want to have something that will help you with solving that problem. The other thing is use that binder. Use it when you study, use it when you go to practice, and use it when you're in competition. Right. I see. Stuff it all in your notebook. But here's the key thing. It has to be in a 3-ring binder. Okay. And 2, you need to be able to find it. So a lot of the stuff like rules and very important pages, like maybe formula sheets, my teams, they would actually put it in one of those plastic protectors so it wouldn't rip out. Okay. Then the other stuff, they had tabs so that they could find it real easy. Again, you make it as useful as possible. And then as far as old tests, you want to be able to find a similar problem so you can see how that problem is solved. And I would agree to put it all in, but just remember, you have to be able to find it quickly. All right. Are there any more questions on machines or circuit lab? Either one. Going once, going twice. Listen, I want everybody. I want to thank everybody for taking their time. I will be having my next one 1 week from today. It'll be at the same time on Sunday. Then I'll be taking 2 weeks off for Thanksgiving, and then we'll start it up again in December. Again, I hope this is useful to you. And please tell others that they're more than welcome to either watch the videos and or subscribe. Thank you, everyone.